and thank you, Valerie, for invitation for this seminar. Welcome in this virtual space. Indeed, I spent 5 years in the agronomy hall on the second floor, and something which always puzzled me about large number of doors in agronomy hall, and which indicates that how many directions, ways, staff, students, and faculty can expand their research well beyond agronomy. Maybe about 2 years before my graduation, I got lost in the Heady Hall. Heady Hall, it's a tall economics building just down the road, and I entered the room which had a lecture in econometrics, and I was too shy to leave. I stayed to the end, and I was really appalled by how you can use mathematics and logic to explain and communicate a lot of different economic problems. The next day, I bought a calculus book, and it changed my life almost forever. And that's where I am now, a focus on analytics and data science. So don't be afraid to lose somewhere, whether it's agronomy hall or somewhere on the campus. It may help you a lot down the road. The focus of my presentation today is on digital early imagery, but I briefly will, I think I cannot advance my slides for some reasons. Sorry, I had a problem of advancing my slides.
That's okay, Dr. Kyveryga. Take your time.
Just a second.
Yeah.
I think I could before, I cannot now. Oh, I can.
Yes.
So here's the game plan for my presentation. Since I have affiliation with the agronomy department, I'll describe several collaborative projects with the faculty and students. And then I focus on the imagery part, which is important in different ways, whether you're in soil science, plant breeding, seed science, crop physiology, or sustainable agriculture. I'll describe a little bit about the project we conducted for the last five years, focus on quality and calibration. And I'll show you one of the tools we developed. It's called VITSIT. It's an online vegetation index time series tool, and how this tool can be used in teaching, extension, and education. And finally, I'll talk a little bit about economic benefits of imagery and also different research opportunities with in-campus and different groups. So here with Iowa Soybean Association, we engage in different types of on-farm trials and different environmental studies. Although I've been with Iowa Soybean Association for the last 13 years, my title changed, but the mission is the same: how to advance collection and analysis of this data so farmers they can use for decision making. So this is the map of different studies and trials we conduct with farmers across the state from 2018. And most of them include some of the data collection, and my group analytics is working with this data. So today I'll focus only on one, focus on the imagery part. I'll mention several joint collaborative projects with agronomy faculty. Several years ago, we realized that reports we create for farmers and those reports for the on-farm state trials were not sufficient. Farmers needed something more, especially something interactive so they can help them make decisions. And we decided to develop a tool which would create this summary online, both statistical and visual. And we couldn't handle this alone, so we were very lucky to contact Dr. Fernando Migas, and then later his graduate student Annabelle helped us to develop this platform, which is called ISAFest, Interactive Summaries of On-Farm Strip Trials. And Annabelle published a series of good papers, and there is also growing interest in tools like this from different states, and we plan to continue developing this platform for other states as well. Another good collaboration we have is Dr. Sotiris Arkantolis group, a laboratory. Several years ago, we had two grants. One through Iowa Nutrient Research Center, and the second through Iowa Department of Agriculture and Landform projects. These projects are focused on using modeling and data from farmers' field. In these fields where a farmer planted cover crop, we established plots with control without cover crop, and we collect continuously water samples, water flow, nitrate, and we're trying to develop the system so we can predict excessive leaching of nitrogen. And here's, we're almost ready to develop a publication, a manuscript, which will focus on cover crop impact on yield and nitrogen loss, and how we can use both measurement and modeling from farmers' field. This is another project, joint project with Dr. Michael Castellano. This is the grant through Iowa Nutrient Research Center, where we share some of the location of our Iowa Soybean Association multiple rate nitrogen trials. Another project which just started a couple of weeks ago, it's a National Science Foundation grant with Dr. Danny Sin as a principal investigator. It's focused on developing and testing so-called smart integrated farm networks for rural agricultural communities. There are other Iowa State researchers involved and other states from Kentucky and Missouri, but we will be working with farmers from Iowa Soybean Association or affiliated Iowa Soybean Association, testing different technology, how to collect different data, summarize, and develop these local communities for making a better decision and increase profitability and decrease environmental pressure. One of the main job, especially in the last couple of years, is to develop so-called interactive management decision aid tools. And this is the screenshot from Iowa Soybean Association website where you can find some of these tools. Most of them are public. So the first tool I mentioned is ISOFAST, which is focused on strip trial summarization. The second tool I'm going to talk today at my presentation. And the next one is focused on soybean variable rate planning. It's a project which we have done here. Brad McArthur, he is a distance MS student in agronomy. And this is his project. For the last year, we developed this tool, and he will present this tool next month as in his defense. The idea of this tool is to utilize farmers' data, farmers' historical soybean yield data, and use different analytical techniques to classify this yield, and then apply different simulations so it can be helpful farmers to decide whether the variable rate soybean planting makes sense or not. And if you're interested in this tool, let us know. We can share some of the data and some of the ideas. But again, that's also related to the agronomy department. This is another grant which we just secured a couple months ago. This is through Iowa NRCS. It's a conservation innovation grant. It's focused on developing a platform for soil health test summarization for farmers and agronomists. I know that many faculties and students are engaged in soil health research in the agronomy department, so could be an interest for you as well. But the idea is to use different soil health systems, summarize them, analyze, and make them more accessible for farmers. Some of this part will be focused on strip trials, some of them just on soil health test, and so on. So if you're interested, let us know. It will also include some of the economic simulations as well. And now I'm ready to switch to my main topic about digital aerial imagery. If you have some questions about those joints, collaborative projects, let me know. Imagery, it's a big deal, especially recently. There is clearly a renaissance in imagery collection and imagery technologies for the last couple of years. When I was a student there in the agronomy department, my advisor, Dr. Alfred Blackmer, he liked to take picture from the plane. So we rented the plane with the hole in the bottom, and then he asked us students to fly with him so we can tell the pilot where to go. And I remember I flew 3 times, and those were the worst days of my life. So I'm happy I'm not a pilot. But definitely now, many farmers have drones, we have drones, blue satellites, so it's clearly the renaissance in remote sensing. Of course, in addition to ability of collect imagery, there are different products, type of imagery. Here on the left, it's a thermal imagery, which indicate plant temperature or potential water stress and so on. And of course, you can apply a lot of analytics. This is an example where you can test your coding ability, how to detect different count to plants from the aerial image, like in this case, I've done a couple of years ago. A lot of different imagery sources and products. Most of them have a name called crop health maps. Here on the left, it's one of the recent adventure called chlorophyll index maps, and on the right, the most also common called NDVI index maps, which indicates different stresses, potential productivity, and biomass. Before I go to the project, I'll stop a little bit about the basic of remote sensing. We have to remember that aerial imagery is based on the sun. The radiation from the sun comes to the soil or plant surface. There are 2 different processes, absorption and transmittance. And then what we do, we try to measure the reflectance. And there are so many ways, there are so many factors which affect this reflectance. Of course, usually we try to break this reflectance into different bands or indices. And again, a lot of time, what we're going to talk today is focused only on 2 parts, visible and infrared. That's what usually in aerial digital imagery. Some of this is very sensitive to the chlorophyll absorption, and some of them for the plant biomass or cell structure, like the infrared spectrum. But again, this is only a part of the big picture of remote sensing, modern remote sensing in agriculture. What we learned that a lot of time, of course, we work with farmers, with many farmers over time. And for me as a scientist, the best way to start conversation with farmers is to start talking about imagery. Especially farmers like to talk about imagery of their fields, but they also like to talk about imagery of their neighbors. So even if I'm not an extension person, that was really helping me to get conversation started a lot of time with farmers. But the problem, what we found that farmers' perception of imagery usually as a picture, and a lot of time, if they collect their own or they buy imagery, they would put in this frame, and that's it. So about 5 years ago, we wanted to change this perception. We wanted to show farmers that imagery is also a digital tool. So we established a project and established a site. It's about 200-acre site. It's in Story County, just northeast of our office in Ankeny by Collins. This site has several corn and soybean fields. This is farmed by 2 farmers. And we work with, for the last 5 years, work probably with about 20 different imagery providers. We flew this site, or the company flew this site every 10 days during the growing season. We established a protocol how to test the quality of digital aerial imagery, and we do a lot of checking, a lot of assessment. And one of these assessments is focused on spatial accuracy. So by spatial accuracy, it indicates the true location of the imagery and true location of the subject on the imagery. So we deploy these high-tech bucket leads, which we can buy from McArtor for $3–5. And then we recorded GPS, high quality, high accuracy GPS, and we can test the spatial accuracy of imagery. So here on the bottom, you can see that the error, the spatial error is about 5 feet, which is more or less normal, sufficient, okay. Here on the top, it's about 25 feet. So if for the big field, it's not a big deal, but if you are trying to develop some kind of specific target strategies, either sampling or treatments, or maybe you do some research with small plots, this can be a big deal. So again, we do a lot of different assessment, and spatial accuracy just one of those. Another thing to remember about digital imagery, aerial imagery, that it doesn't have units, unlike like yield, which has a unit of measurement of bushels per acre, or temperature, it's measured in Fahrenheit or Fahrenheit, so other units, imagery does not have. A lot of factors can impact the reflectance, and here's this puppy. Imagine that looks like it tells 60 pounds, which a little bit unbelievable. So one of the solutions to this lack of units is using different ratio vegetation indices, but again, there's many factors can impact these measurements and units. So what we decided to do, we decided to establish a calibration protocol. And this is the same like you probably calibrate your pH meter in the lab. And there are different ways to calibrate imagery in real conditions. One of them, you can use satellite imagery as background. It's done. It's require a little bit knowledge of both. Some people trying to use active crop canopy sensor mounted on drones. There is a project in a company in Nebraska which is developing this technology. We can also use reflectance from different permanent ground feature like building, roofs, roads, concrete pads, and other stuff like that. Also, it requires a little bit manual work. There is also different types of sensor which are equipped. Modern remote sensing system and planes have them. They're also helpful in some cases. We also can use so-called on-the-ground painted tarps and targets, which that's what we used when I was a graduate student. So all of these potential ways can be used to calibrate imagery, but we decided to use slightly different way, the most reliable. These are so-called manufacturers imagery calibration tarps. We work with a group from Southern Illinois University of Edwardsville with Dr. Randy Pearson and his student Josh. And they recommended us to purchase these tarps. These are tarps which have a known reflectance value. Originally, we bought it only 3, 6, 12, 33, and we quickly realized that it's not enough for calibration, because a lot of time the imagery, the reflectance, the real reflectance from the plant canopy and soil can be in different extreme. So then we usually have different types of tarps, small, bigs, and medium. Each time the system flies, we deploy these tarps. It takes a lot of effort to communicate with different providers. We also know that these tarps, a lot of creatures like dog, pets, cats, coons like these tarps. Also, you notice that the farmer accidentally mowed this one, and we have to replace. So yeah, it's very time consuming, but it's the most reliable way to calibrate aerial digital imagery. And every time the system flies, we deploy this tarp. So what does it do? So here on the top, and again, this is the calibration site we established, 200 acres. There are soybean and corn fields. This is an example of calibrated versus uncalibrated NDVI. It's one of the index, which I'll talk a little bit later. So here I started from July 5th. This is calibrated on the uncalibrated on the top, calibrated on the bottom. You notice for uncalibrated imagery from the imagery provider, the scale is very relative. There's no number. That's what usually farmer would get from a provider. The green one indicates higher biomass. The red one indicates lower biomass. And you may notice that there is some inconsistency with colors. If you look at this cornfields here, it was yellow, became red, and then became yellow, and so on. So the image only good for one time, for one date. There is no way to make comparison between the date across the time. Here on the bottom, you notice that we have a common scale, and it's calibrated using the Tarps. And now we can compare this imagery and using this digital data analysis. So if you want to look at the whole time series of this imagery for this specific year, for this site, this is from May 22nd through September 1st. So now, by putting this in the common scale, we can develop this time series and look at some of these trends in these indices or reflectance values. And again, here we have two different crops, so you can see that in different time, NDVI of corn were higher early, and then later definitely soybean had a higher NDVI and so on. But again, using the calibration allow us to put everything in a common scale and have this data ready for analysis. Of course, looking at imagery, it's one piece. That's what farmers like to do, but we wanted to develop a system so we can test digital performance of each of the grid cell size and yield. So we established this grid system. It's 75 by 75 foot grid system for all of these fields, where we can aggregate yield in the end of the season. So here's the yield map. The red one indicates lowest yield, the green one indicates the highest yield. And then we try to connect each of these grid cells with individual reflectance or index for both calibrated on the left and calibrated on the right. For example, if you look here on the right, this is the green reflectance. Notice that for uncalibrated imagery, the green reflectance is in digital units. And these digital units can go in different ways. This is 8-bit imagery, if you understand this. So the range is from 0 to 256. The red lines should indicate the higher yield. So you notice that looks like the higher the green reflectance, meaning that there is less chlorophyll, the yield tended to be lower. So these red lines on the top earlier. And then you can just follow this. Of course, this is uncalibrated imagery. If we calibrate this using our Tarps, then we have a time series like this on the left. So here, all of these reflectances, like green, is expressed in percentage reflectance. So now we can establish this time series and notice that there is a nice separation, especially early where the low yielding area have a high green reflectance earlier. Then there is a saturation in green reflectance and also some separation later. But when we ask farmer which imagery would you prefer, most of them would tell us on the left, so calibrated. This is just corn, and this is just green reflectance. Of course, in modern remote sensing, there are so many indices. If you look at the literature, there are probably hundreds of these different indices. And we just choose here 15, the most common ones, like NDVI, SETI, chlorophyll index, and so on. So the literature just full of this. So you can do a lot of different combination of these indices for different purposes. Of course, we collected all of this data from a bunch of different systems across 5 years, a lot of data. So how are we going to analyze? How are we going to show this? We decided to develop a tool, an interactive tool, and this tool is publicly available. You can go online. It has a name, a Vegetation Index Time Series Interactive Tool, or VITSIT. This tool allows to select a year and a field, a different crop, and different indices. There's also a YouTube video which kind of explained the logic of the tool and how to use it. And Suzanne, our data analysis, she created this YouTube video. The tool allows to look at these 15 different indices or bands, and you can choose from the drop-down menu. So again, the data comes for the last 5 years, both for corn and soybean, and different indices. So here's what this tool can do. And again, this is soybean now. And now I'm looking for the near-infrared. The near-infrared band is responsible or correlates with the cell structure or biomass. This is the soybean field. The green indicate a high yield, the red indicate lower yield. This is uncalibrated. So again, you can see some trends where we're trying to figure out what's the best time to collect imagery and where is the highest separation in these different yielding zone or management zone, whatever you call them. So here's uncalibrated, infrared, on the left calibrated. You notice that definitely there is a clear separation earlier and much better separation later, where there is a nice progression of, as a high infrared indicates high yielding area, low infrared indicates lower in the area. So the question is how we can optimize this by deciding on the best timing of flying and the best index. A little bit about NDVI. It's the most common index, which was developed in mid-70s, or the time when I was born, to assess growth different crops using satellite imagery. But you may notice here that at some point NDVI saturates, so it goes to this maximum, and this is because of the red reflectance and partially infrared. But again, for this specific field, soybean looks like the best separation in this category was in the end of the season. Of course, in NDVI, it's only one. Again, you can choose different indexes. Another feature of this tool, and this is corn, you can select not just individual grid cells, you can select averages for categories. And also you can compare these time series with previous growing season. So the same crop, but previous growing season. So for example, here I have a 2015 and 2017. You notice that in 2017, the corn was planted here a little bit later. It looks like they have the same slope early on. And also, there was no much separation between these yielding categories earlier, but was clear separation later in 2017, which is also indicates here on this individual image. So again, visually, it tells the story about these time series of these calibrated sequences of different indices. That was corn. I'm switching now to soybean. Again, this is NDVI at this point. This is 2017 individual cells. I'm going here and trying to compare the averages for these categories for 2017 and 2015. So you notice that the time series patterns are different. Looks like there were a lower slope in 2017, and we also saw a much better separation in these categories earlier in 2017 than in 2015. If you looked at the end of the season, it switched. Actually, in 17, there was no much separation, was much better in 2015. So by studying these time series, they can tell us a lot about the performance, the growth and development of crops, which also can be used potentially for future modeling and predictions. But again, the feature of this tool that you can switch both from individual cells to the averages for different categories. Another feature of this tool that you can also put, of course, this is one way to look at categories and look at the separation in space, that's fine, but how about having something more quantitative? Of course, we as scientists like to have a look at correlation maybe. So here's the tool allows to plot correlation. So this is the correlation of imagery or index from imagery, in this case green, with the yield and each time of collection of imagery. So here's for corn. I'm using just green reflectance. It's calibrated in percent reflectance. You notice that correlation, and there is another axis here which show the correlation, and looks like correlation were always negative with green, which makes sense. And also they tended to increase toward the end of the season. That's for corn. If you look for soybean, and again, this is 2017 example, in this case, a correlation with NDVI were positive, and they actually tended to decrease over time. So they were the highest early on in the season. You see this nice separation in space. And the reason for this that often, at least for this field, the soil have big impact on yield earlier. That's why it's important to study these patterns over time, and having these calibrated data and tool like this would allow us to look at this. I mentioned that you can choose different indices, and I want to show you just one. This is called chlorophyll index, green. It doesn't have red. It's based on infrared and green. It's became quite popular recently by some companies because it allows to focus more on nitrogen stress and chlorophyll and stuff like that. So here on the left, we have a corn. You notice that this index, this chlorophyll index or CIG, it doesn't saturate. It has a nice separation, nice slope earlier, but then it has this up and down valley in the middle of season. You may wonder why it's happening. In some cases, it's because of tasseling and silking of corn, but it's also common for soybean as well. If you look here on the right, it's also common for soybean. It's what's the good news that these patterns they're consistent. We're plotted here using 2 years of data, or 15 and 2017. It looks like this pattern the same. So again, in terms of modeling prediction, that's a good news. Another feature of this tool, it also plots the daily rainfall for these fields and years, and it's important since rainfall may affect some of these indices and also calibration quality. So for example, for these dates, we believe that there was some impact of excessive moisture, excessive rainfall on some of these indices, both on calibrated, but much more for uncalibrated imagery. So again, this tool will allow to plot these different indices and also show rainfall, daily rainfall over time. Another important feature of our analysis, we're focused on shape of these imagery calibration equations. I mentioned before that having these 6 or 7 or 8 Tarps, it's a pain. They're not cheap. They degrades over time, so we have to manage them, clean them. So the question is, can we use just 2 or 3 Tarps? So here on the right, this is so-called, we're looking for the shape, this relationship, we call them equations. This is the digital number. This is the digital number which comes from the imagery from the provider. In this case, it's a 16-bit. You notice the big numbers. And we try to correlate or relate to the percentage reflectance from the Tarps. And you notice that everything looks like more or less linear, which is good. If it's linear, then we may get away maybe with just 2 tarps, maybe 3 tarps. So we don't need to manage all of this. If you look here on the left, that's another example where the calibration equation is not linear. It's some kind of exponential growth. We have 3 different tarps. The good news that all of these tarps agree, but it's not really linear. So again, one of the goals of our research and testing was to identify which system can produce this linear shape in calibration. So what we learned that a lot of time when you buy an imagery or farmer get imagery, the providers would process, truncate, or enhance, and this preprocessing would change the shape of these calibration equations, big way. So you have to always ask providers about the raw data, and not all of them will provide. Another important issue is that usually if you want to have a better quality for calibration and linearity, it's better to have 16-bit imagery than 8. And that's probably also relates to the pre-processing imagery truncation, because dealing with high volume imagery is not easy, especially for 16-bit and so on. Okay, so what, that doesn't matter. Okay, why this calibration so critical? So this is an example of so-called sensitivity analysis, and we published this in last year ICM conference, it's Integrated Crop Management Conference for the agronomist, extension agronomist, and agronomists across the state. So here's an example. In this case, we take the same red reflectance. We keep it constant, 3%, which is pretty low. And then we change the near-infrared reflectance by 10%. So we're going from 75% to 65% and 55%. You notice that the change in NDVI, it's about 300, which it sounds like not a lot, maybe. But let's keep the near-infrared the same, but change red reflectance only by 1%. Imagine, only 1%. You notice that NDVI would change about 600s. That's NDVI units. So 600s can be a lot. It can translate to several bushels of corn and well, maybe to a dozen bushels of corn and several bushels of soybean. So again, that's very important. And having this sensitivity analysis data can help us to check and have a better imagery product. I mentioned that we work with about probably 20 different companies for the last 5 years. Some of these companies almost gone, some of them were bought, some of them got bigger. And sometimes when we started working with companies, they would a little bit skeptical why we're doing this and what it's all about. But this is example, one of the company where the first year we worked, they really questioned why we use those Tarps and so on. But the next year, in early July, actually last year, I got this message. And the person is asking Peter, where did you get those Tarps? Can you advise for manufacturer? And the good news that at least currently, many imagery providers are working on this issue. They're testing different systems. Of course, they're also buying these calibration Tarps. And hopefully for us, we won't buy this in the future. We also have many questions about satellite imagery. Our tool has some satellite imagery as well. You can find it has a name SAT, a satellite. This is the example of Planet Lab imagery. This is for 2019. So Planet Lab system, they have a constellation of about almost 200 satellites. They fly quite frequently. You see that they fly almost every several days. Here on the left, this is the green reflectance. It's uncalibrated. You notice that very nice separation, very consistent early, but the problem is that we have these spikes. and we still don't know why. We filtered our data, we cleaned our data, and the same is for green NDVI, GNDVI. Again, for some reasons, there are these spikes, and that's what we often see with satellite imaging, which indication that maybe some of the systems or some of the satellite have different cameras or different calibration, whatever. But usually satellite imagery should be normalized or calibrated since they fly a big area of land, and it allows them to normalize data in space and time. In the end, I want to mention why it's important and when the calibration is needed or critical. So again, this is the table from last year ICM conference where we listed different practices where calibration is needed or required. This is just for soybean, but it's the same for corn. You notice that we mentioned whenever we need several images, calibration would be really helpful. That's for if you're trying to identify zones of yield variability, maybe detect a disease area early before you can see symptoms. If you try to predict yield, do modeling, or maybe early detection of water stress. Here's also several examples of where calibration is preferable. For example, because of the strong wind early in August here in Iowa, having calibrated imagery, it would be much easier to assess or quantify the damage since you can do a quantity analysis. It can also be used for detecting, quantifying iron fluorescence area and also quantifying residue. About economic benefit, whenever you can do something and these actions will produce, save you money or increase yield, definitely that will show the potential economic benefit. Here are several practices where calibration is not needed. That's for scouting, for plant stand count, guiding of soil and plant tissue collection, detecting drainage problem, herbicide overlap, and so on. Calibration is not really needed. So one-time image, wherever it doesn't matter. Again, I choose this topic because there are so many ways to collaborate and expand this. And last year we got contacted by a group of scientists from Iowa State Computer Science Department and Agriculture Biosystem Engineering, and also from University of Iowa Business Analytics. These researchers, they specialize in AI research or AI development, and what they like about these tools and this idea that we can expand these ideas to developing different platforms for making AI solution for in agronomy. And we applied for a couple grants. Some of them we were not lucky. Some of them still in review. But again, this area, especially using the imagery technology and using farmers' data, are very important. So in conclusions, my point was that whenever you do research with imagery, be cautious about imagery calibration and realize that for doing a lot of temporal monitoring and accurate analysis, it can be important. The tool I showed you, it's publicly available. It can be used in extension, undergraduate teaching and education. I know University of Nebraska was planning to use this and teaching this fall. And last spring, we had several lectures for the University of Missouri, and I got comments from one of the scientists. He said that, well, I wish I knew this 20 years ago, so I would change my research completely from that point. But definitely that's better late than never. And again, there are so many opportunities in this space here, both in agronomy and conservation and other areas focused on analytics, data science, and decisions. Well, and definitely gonna respond to a couple questions. And if you want to find these tools, you can go to the Iowa Soil Association website. You go to the home, ISA research results, and then you can see these tools. And if they don't work or you see some problems, let us know.
Thank you, Dr. Kyveryga. Any question to Dr. Kyveryga?
I had a quick question. How accessible is it for farmers to get images like commonly? Like, would you say that a lot of farmers in Iowa or in the regions that you work have these images, or is it an extra cost for them to get the image and then, you know, go through this process?
Yeah, the question is about how accessible is imagery, or how affordable this imagery. Often, especially in the past when prices were high and many farmers bought drones. Many farmers have drones. They collect their own imagery. And many of these farmers who are working with different providers, they provide this imagery as not really for free, but as a package, like for climate view and other different decision tools. But it costs about, it's still expensive. It costs about, if you have one flight, it would cost from $150 to $2 per flight if you buy it from providers. So again, it can be expensive, especially in large areas.
Dr. Kyveryga, I also have a question. Again, that was a great presentation. Thank you so much, Dad, first of all. My question is regarding satellite imagery and aerial imagery. You mentioned that calibration is needed when we are using UAVs. Do we also need calibration if we are using satellite imagery and aerial imagery, especially for variable fertilizer rate applications?
Your question about calibration for different systems. Calibration may not be needed, but especially in the research setting, you have to be aware and maybe check. Especially some of the modern drone system, they have a procedure for developing their own calibration, and also depends on different cameras, different camera system, different purposes. For variable rate application, it depends what kind of application. It depends whether these variable rate prescription are based on multiple imagery or just one-time imagery. If it's multiple imagery, calibration would be helpful. Well, some kind of normalization would be helpful.
Thank you. And we have another question from Laura. Laura asked that you mentioned that some farmers have drones and take their own imagery. If a farmer wanted to get started with this, what things should he look for in drones or cameras, she asks.
Yeah, the question is about drones and their own imagery and what they should look for. Definitely the cost. There are different drone systems, some expensive, some less. The cost is going down very dramatically. If it's only for scouting, the calibration quality doesn't really matter. That's what usually farmers use. Most of drones use for scouting. And different cameras can be equipped with different system. There is also different sensor in addition to cameras, which allow to address or measure these irradiance or different scatter or reflectance due to sunlight, wind, weather, and stuff like that. But for farmer, if it's only for scouting, it doesn't really matter.
We had a quick clarification question. Did you mention what height the UAVs were flown at, and how would that impact, I guess, the image quality?
Yeah, what's the height of UAV drones? It depends on the purpose. Some of them can fly quite low, especially if you do for stand count. There's also some restrictions for the height. Those people who have a license or pilot license to fly drones, that they know this. It depends what purpose is, and also what cameras use, because when drones are flying, they collect a multiple imagery from a site. It's not just one. And there is a process of processing, stitching, and mosaicing, and that's also a lot of problems with imagery, especially for digital analysis. And that's one of the evaluation we do with our partners from Southern Illinois University, where we look at these patterns of mosaicing, stitching, and so on. Sometimes different bands can be misplaced in different places in space and time and so on.
Dr. Kyveryga, I also have a question, another question. So is the calibration for UAV the counterpart of the atmospheric correction done in satellite imagery? Are they like counterparts, like similar things?
Well, they have a sensors. I believe they have a same, that's the same. So both of those systems have different sensor to measure the radiance or scatter. But definitely in satellite, they're at much different height. But I think satellite imagery is much more consistent because you're capturing a large area of land.
Right.
So for example, you can calibrate the imagery to like the Sahara Desert in Africa and Amazon forest, something like that. Of course, there are some also aerial system which allows to collect imagery, big sources of imagery too, which also more or less normalize.
I see. Thank you so much. We have another question from Dr. Prashant Jha. He's asking that, are you using imaging technology for precision weed and pest management?
The question is about using the imagery technology for precision weed and pest management. We use as a scouting tool, not as a digital tool, unfortunately. Very occasionally we can, we've done some analysis, we published some papers, but we don't do much for weeds and pests, except for scouting.
Any more questions to Dr. Kyveryga?
Peter.
Yeah, hi, Dr. Cotton.
Bob Horton. I don't really have a question, but since we have a lull, I just wanted to say hello. It's been a lot of years since we used to bump into each other up on the second floor of agronomy.
Sure. And I still remember the advanced soil physics class. That changed my mind too.
Well, good. I hope it's good memories and not bad memories. So
no, very good.
Good.
Very good.
So I enjoyed your presentation very much. Thank you for reminding us, me and all the others, that it's good to evaluate, to test our measurements, you know, not to just assume everything is accurate and correct and useful, but to do some tests. So I'll just contribute. I don't really have a question, but I'll just say, because I know a lot of people do use models, and many models have built-in parameters that are based on what we call pedo transfer functions. So I would just say for soil hydraulic properties, it's really good to get a ground truthing or a matching point in your field, because they can be very far off without that. And so I just want to say that you're reminding us to be careful and to get ground truthing or matching point or calibration, I think is really important. So thank you for that today. It's good to see you also.
Thanks for the comment. Thanks. That's exactly what the point of this.
We got one more question from Dr. Manu, actually. From your experience, will you recommend a fixed wing or rotary platforms when using drones? He asks.
Yeah, the question is about the fixed wing versus rotary platforms. We tested both of these. It depends whether you want to fly big areas, small areas. We didn't really see a difference in calibration quality. It all depends on the providers, camera, and conditions. So I don't have any preference for these. Of course, the fixed wing will allow to fly a larger area compared with rotary in some cases, but that's not universal.
Valerie. If you don't have any questions, any more questions, would you like to close the meeting?
Yeah, we'd like to thank everyone. We do have a reaction button, so feel free to do that if you feel comfortable. Thank you so much for the presentation, Peter. Reminder for the rest of the participants that next week we have Dr. Kendall Lamke, and he's going to give the State of the Department address. It's going to be the same Zoom link, so we'll see each other next week then.